Hello, my dear students, and welcome to the new lesson. In this lesson, we are going to learn about the constants. So, what is constant? A constant is a value which does not change during the execution of a program. So, unlike variables, variable will change the value during the program, but this value, which constant value, does not changes during the execution of program. So C supports three types of constant, which are integer constant, real constant, and character constant. So integer constant is a constant containing only the digits with plus or minus sign. This type of constant does not contain a decimal point. So whereas in real constant compulsorily will contain a decimal point. So these are the constant having decimal point, means these are the fractional values. And the third type of constant, which is a character constant, which can contain a single character or the multiple characters. So we will discuss each of these constant in detail. So firstly, we will discuss about the integer constant. So a integer constant is a sequence of digits preceded by optional plus or minus sign. And there are three types of integer constants, namely decimal integer constant, octal integer constant, and the hexadecimal integer constant. Actually, these types of integers are according to the number systems. So this first integer constant, which is decimal integer constant, this constant follows the decimal number system, which contains the digits from 0 to 9. So from childhood or in our day to day life, we are using the decimal number system. So therefore this decimal integer constant also contains the digits from 0 to 9, and it can contain plus or minus sign. So any number having digits 0 to 9 is considered as the decimal integer constant. So for example, this number 123 is a decimal integer constant, minus 31, 0, and so on. So this is about the decimal integer constant. So other types of number system are octal number system and the hexadecimal number system. So this octal integer constant follows the octal number system, which contains the digits from 0 to 7 only. So our decimal integer is also having the digits from 0 to 7. Then how to differentiate between these two numbers? So to differentiate these two, an octal integer constant begins with a 0. So any integer constant having digits from 0 to 7 and which is preceded with or which begins with 0 is considered as the octal integer constant. So this 0 to 6 will be considered as octal integer constant, and if you simply write 26, then it will be considered as the decimal integer constant. 0347, it is also the octal integer constant. So any constant which preceded with 0 and having digits from 0 to 7 is considered as the octal integer constant. So the next type of integer constant is hexadecimal integer constant, which follows the hexadecimal number system, and it contains the numbers from 0 to 9 and the alphabets from A to F. So this A to F can be in small case or in capital case. So here in this integer constant, capital case letters or small case letters doesn't matter. So any number having digits 0 to 9 and the alphabets from A to F and which is preceded by 0x is considered as the hexadecimal integer constant. So for example, 0x8c, it is a hexadecimal integer constant. 0xbcd or 0x45f or 0x123 will be considered as hexadecimal integer constant. So this is about the integer constants. So let's do some exercise. So here you have to identify the type of constant. So the first number is 896. So of course it is a decimal number, integer constant, as it contains the digits 8, 9 and 6. Then the second number is 0x23ab. So it contains digits and the alphabets AB, and also it is preceded with 0x. So therefore this is a hexadecimal integer constant. 0345. So this number is preceded with 0 and having digits from 0 to 7. So therefore this is a octal integer constant. Then the next number is minus 8563. So of course this is a decimal integer constant. Then the number 0x123. So it is preceded with 0x. So it is a hexadecimal integer constant. Here the number is ABC, but ABC contained in the hexadecimal integer, but it is not preceded with 0x. So therefore this is not a type of constant. So it is a invalid constant. And the next number is 0567. So this number is preceded with 0. So hence it is a octal integer constant. The next type of constant is a real constant. So the real constants consist of a fractional part in their representation. That means a real constant will contain a decimal point in their representation. So integer constants are sometimes inadequate to represent quantities such as height, weight that vary continuously. So you cannot represent height using a integer constant, or you cannot represent price using a integer constant. So you have to use a decimal point to represent the quantities like height and weight. So these quantities are represented by numbers containing fractional parts. So like 26.082. So any number having a decimal point in it is considered as a real constant. So for example 0.0026 or minus 0.97, etc. So any value, so this value, see this value 487.0. So as in mathematics it is 48, it is just like 487, but in C language 487.0 is not equals to 487. So this 487.0 is considered as a real constant, and if you write simply 487 then it will be considered as a integer constant. So sometimes real constant can be written in exponential format. So generally why we use this exponential format? If a number is very small or a number is very large, then instead of writing number of zeros after the value or before the value, we can use the exponential format. So exponential format is written like this: mantissa e exponent. So for example, see this example 1.2 e minus 5. So here 1.2 is a mantissa part and this minus 5 is the exponent part. So if you write a number 1.2 e minus 5, then it is equivalent to 1.2 into 10 raised to the power minus 5. So which is equals to 0.000012. So instead of writing number of zeros, you can write it in exponential format in this way. So similarly here 0.5 e plus 7. So here exponent is a positive value. So this value is equals to, so this is equivalent to the value 0.5 into 10 raised to the power 7. So which is equals to 5000000. So instead of writing number of zeros after 5, you can write it in exponential format like this: 0.5 e plus 7. So we'll see about the next type of constant, which is a character constant. So the character constants are divided into two types. So which is a single character constant and a string constant. So the single character constant represents a single character which is enclosed in a pair of single quotation marks. So for example, here a character, single character 5 is enclosed in single quotation mark, so it is a single character constant. So here X is enclosed in single quotation mark, semicolon is enclosed in single quotation mark. Even if a space is enclosed in single quotation mark, then it is considered as a single character constant. And every character constant, every single character constant is associated with a ASCII value. So as we know that every key on keyboard have its associated ASCII number, which is American Standard Code for Information Interchange. So every character is having ASCII value. So therefore every single character constant is also having its associated ASCII value. So for example, if you write capital A in single quote marks, then it is considered as a value 65. Similarly, if you write capital B in single quotation marks, then it will be considered as a value 66. Therefore, these type of constants can also be used in calculation also, as they are having a associated value. So associated number, it can be used in calculation also. So for example, if you write capital A plus capital B. If you write in single quotes capital A plus in single quotes capital B, then it will be equivalent to the value 65 plus value 66. So therefore, this type of constant, that is single character constant, can be used in calculation also. So the next type of constant, which is a string constant. String constant is very simple. So actually, if you include number of characters in double quotation marks, then it will be considered as a string constant. So here characters 1, 2, 3, 4 is enclosed in double quotation mark, so it is considered as a string constant. Here in double quotation God bless is written, so it will be considered as a string constant. So actually string constant are used to make a program in readable format. So we will be using we will be learning this string constant in detail in our next lectures also. So let's do some exercise. So here you have to identify the type of constant. So firstly consider this example. So here digits are enclosed in double quotation marks. So therefore if you enclose anything in the double quotation mark, then it is considered as a string constant. So therefore the first type of value is a string constant. Next, consider in single quotation there are x, 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 x. So you know that in single quotation mark you can include only a single character, and here there are multiple characters are enclosed in single quotation marks. So therefore it is a invalid constant. It is not any type of constant. So next the value is 0x345. Here a 345 is preceded with 0x. So therefore it is a hexadecimal integer constant. Next the number is 3.4 e minus 9. So of course it is a real constant but in an exponential format. Next value is 0, 1, 2, 3. So 1, 2, 3 is preceded with 0. So hence it is a octal integer constant. Then here a single character is enclosed in single quotation mark. So it is a single character constant. Here the value 2.5 rupees. So any constant cannot have the other characters except the digits. So hence this RS is not supposed to be a part of constant. So therefore this is an invalid constant. The next number is 45. So of course it is a decimal integer constant. And the next 5.236, it is considered, there is a decimal point here, so therefore it is considered as a real constant. So here we have completed with the types of constants. So this is all for now. In the next lesson we will be coming up with new learnings. Thank you.